Hi, this is Ms. Moser, and welcome to a quick tutorial on using what you know about moles to do some molar conversions. This is also known as your introduction to stoichiometry. It's not only fun to do, it's a lot of fun to say. So, what do we know so far? So far, we know some handy things like the fact that 1 mole of copper is equal to 6.022 times 10 to the 23rd atoms of copper. That in fact 1 mole of anything is equal to 6.022 times 10 to the 23rd pieces of that thing. Well, that's a start. What else do we know? You'll need your periodic table. We also know that 1 mole of copper, or 6.022 times 10 to the 23rd atoms of copper, is equal to 63.55 grams of copper. And that we got that number from the periodic table, because in fact 63.55 AMUs is the atomic mass of copper. So that same mass in grams is the molar mass. Well, that seems moderately useful. Actually, it's very useful. So let's remember that 1 mole of anything is equal to 6.022 times 10 to the 23rd pieces of that thing. And then when we're talking about atoms for now, and later on molecules, that same amount of the substance is equal to its atomic mass given in grams. Okay, pretty simple. 3 things. This means we can do conversions. So there were 3 things that all have an equality between them. 1 mole of a substance, 6.022 times 10 to the 23rd pieces of that substance, and its molar mass. Well, we're going to use a little mnemonic. I call it your GMA. You got a GMA, you love your GMA, never forget your GMA and you won't go wrong. So in this case, the G stands for grams. The M stands for moles, and the A stands for atoms, but you probably guessed that already. So we're going to be converting back and forth between these 3 things. We're going to start off going from grams to moles and moles to grams. That's a 1-step conversion. And we know the relationship between grams and moles is given by the molar mass of a substance that you'll find on the periodic table. Let's try one. So the question that we're given is this: 150 grams of aluminum is equal to how many moles of aluminum? When doing conversions, just as you did when doing metric conversions, you're going to use a factor label setup, and your first box, the one right here, is always going to have your given. So in this case, the given is 150 grams of aluminum. Now, we want to end up in moles of aluminum. I'm going to make a note of that. And we know that in any conversion, we want the units to cancel down and in the next box. So what units and what chemical have to appear in that next box? Remember, feel free to use your pause button so you can answer these for yourselves. That's right. The next box on the bottom should have grams of aluminum. And since this is a 1-step conversion, what goes on top of that is going to be the units and chemical we want to end up in. What's that going to be? Remember, use your pause button. Absolutely. That's going to be moles of aluminum. Now, what we have to figure out is what the relationship between moles of aluminum and grams of aluminum is. Here's one of the 10 commandments of doing molar conversions. There's always going to be a 1 in front of moles of anything unless moles is your given. So anytime you're using moles in a conversion factor, it should have the number 1 in front of it. Now, how many grams of aluminum are contained in 1 mole of aluminum? Where do we have to look? If only there was a table of some sort with information. Periodically, I remember what it is. Ha! It's the periodic table. So, 1 mole of aluminum is equal to 26.98 grams of aluminum. So now it's a simple division problem. This gets us a raw answer of 5.5596738, blah, 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 on and on and on. Now we have to look at how many sig figs we're allowed to have. Remember that sig figs are always governed by your given. So none of this stuff counts towards your sig figs. The only thing that's going to count towards your sig figs is the number that you were given to start with. And that has 4 significant figures in it. So your final answer can have 4 sig figs. We'll be going to here and rounding. That gives us 5.560 moles of aluminum for our final answer. Okay, well that wasn't so bad. When you're doing a grams to moles conversion, it's a single step process, and you should start with your given. Units will always, units and chemical, down to cancel, end up with the units and chemical that you want to be in. Don't forget to keep all your digits till the end, and do your sig figs. Now let's look at moles to grams. Okay, you need 2.50 moles of pure iron for something, who knows. What mass of iron is this going to be? We very commonly have to do these kind of problems because while reactions deal with amounts in moles, we don't have scales that can measure a number of moles. So we measure out the mass of a substance to get the amount we need. Okay, we're going to start with our given, as always, which is, don't forget to use your pause button, 2.50 moles of iron, anyone? And what units and what chemical will go down and in the next box to cancel? You got it, moles of iron. Okay, this is a one-step process, and we want to end up in grams of iron. So what units and what chemical will go on the top? Of course, grams of iron. Now, remember, 10 commandments of factor label. The only number that's ever going to go in front of moles, unless it was a given, is 1. So, what's the relationship between 1 mole of iron and some number of grams of iron? That's right, it's the molar mass. Look it up, quick. Okay, 55.85 grams of iron equals 1 mole of iron. Now it's multiplication. Okay, we get a raw answer of 139.625 grams. Now the question is, of course, how many sig figs can we have? Governed by our given, and that gives us 3, so we're going to round there. What we end up with is 1.40 times 10 to the second, because of course this causes that to round up, which means we have 140. So to get 3 sig figs, we do need to put it into scientific notation. Our final answer, 140 times 1.40 times 10 to the second grams of iron. Okay, pretty easy. Moles to grams, grams to moles. Okay, but what about the atoms part? Well, we can go from atoms to moles and moles to atoms. Let's do a few of those real quick. Okay, you've been given a lump containing 7.5 times 10 to the 24th atoms of carbon. How many moles of carbon is this? So now we're doing atoms to moles, working from the outside of our GMA formula to the middle. As always, our given goes in the first box. What units and chemical will go in the next box on the bottom to cancel? That's right, atoms of carbon. And we want to end up in moles of carbon. So what units and chemical will go on the top for our final step? Moles of carbon, you got it. Now, what's the relationship between a mole of carbon and atoms of carbon? Well, again, thinking back to the 10 commandments of factor label, nothing but a 1 should ever go in front of moles unless moles was your given. Now, how many atoms are in 1 mole of carbon? Here's another handy thing to remember. Nothing but the number 6.022 times 10 to the 23rd should ever appear in front of atoms or molecules unless it was your given. Okay, now it's a simple multiplication problem. Because we're using scientific notation here, I've gone ahead and set it up as follows. We divide this part, 7.5 divided by 6.022, and multiply the whole bloody mess by 10 to the 24 minus 23. Raw answer, we get 1.254543, etc., 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 times 10 to the first moles of carbon. How many sig figs do we have? Only 2, as governed by our given. So this becomes 1.3 times 10 to the first moles of carbon. Also totally reasonable to just call it 13. Okay, one last example and then you're on your own. Okay, how many atoms are present in 3.75 moles of zinc? So, we always start with our given, 3.75 moles zinc. Now, you know the rules for factor label. What units in chemical go down and in the next box to cancel. That's right, moles of zinc. This is a one-stepper and we want to end up in atoms of zinc. So what units in chemical have to go on the top? You got it, atoms of zinc. Now, what's the numeric relationship? Remember, nothing except a 1 ever goes in front of moles unless it's your given, and nothing except 6.022 times 10 to the 23rd ever goes in front of atoms unless it's your given. Now, what do we get? Again, we're dealing with scientific notation, but it's sort of a mixed problem. One number's in scientific notation, one isn't. Let's check this out. We multiply the actual numbers and then multiply the whole thing by 10 to the 23rd. Our raw answer is 22.5825 times 10 to the 23rd atoms of zinc. We have a problem, however. Aside from doing our sig figs, we're going to have to move that decimal because we can't have 22 point anything times 10 to the 23rd and be in correct scientific notation. Remembering my trick, I'm going to go, let's see, 1, 2, 3, until I get the hang of it that, aha, moving the decimal this way is going to get me an additional number here. So that'll make it to the 24th. Let's rewrite it. We have 2.25, etc., times 10 to the 24th. Of course, we only have 3 sig figs, so this is going to become 2.26 times 10 to the 24th atoms of zinc. Okay, go look for a practice sheet on Classroom with some molar conversions. See you tomorrow.